Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes.
This video is sponsored by Tagatize, the easiest way to run Tag All on multiple Revit views and sheets. Also, say goodbye to overlapping tags. Tagatize will turn this into this. Try Tagatize completely for free using the link in this video's description. In this video, I want to show you how I use GitHub Copilot inside VS Code to generate Python scripts for Dynamo, and more importantly, how to evaluate and improve AI-generated code through iteration. We're going to walk through a very realistic example using 3 Python scripts that were generated from the same task, but with different AI models and prompts. Let's start with the task I gave to the AI. The goal is simple and very common in Revit automation. We want a Dynamo script that collects all Revit link types in the active model, checks their path type, leaves relative paths unchanged, converts absolute paths to relative, runs safely inside the transaction, and reports the results back to Dynamo. Of course, we can already do this in Revit without using Dynamo, but this small, simple task is a perfect test case for AI-generated Dynamo scripts. To start, make sure you have Visual Studio Code installed. If not, simply do a quick search for VS Code install, get the latest installer, and run it. I've already done that, so let me switch to VS Code here. Once in VS Code, we first need to select or create a workspace. Think of it as a folder where our new code files will be generated. If we select a location that contains existing code files, the AI can modify those as well. We'll see that later in this video. For now, I'll just select an empty folder to start a new workspace. Next, make sure you have the Copilot Chat panel opened. In recent versions, VS Code often has this open by default. If not, click the chat button here to toggle it. There's also a button on the title bar of VS Code that contains several options. One is also for opening the chat panel. Now, if you don't have any of the buttons mentioned so far, you'll need to install an extension to enable the chat panel. It's called GitHub Copilot. However, this is unlikely unless you're on a very old VS Code version. In that case, maybe it's easier to just update your VS Code. Now that we have the chat window ready, let's start vibe coding. Before switching to Dynamo, a quick shout out to our sponsor, Tagatize. With Tagatize, it's never been easier to tag multiple Revit categories at once using your favorite tagging styles. Say goodbye to spending countless hours untangling Revit tags. After running Tagatize on this view, for example, all my tags are perfectly readable. None of them overlaps with their hosts or other elements in the view. If I think this tag, for example, can be placed better, I can just select it and click Next to tell Tagatize to try the next possible tag position. Each time I click the button, Tagatize moves the tag for me, and I can keep doing this until it gets to a tag position I like. There we go. That's much better. Try Tagatize completely for free today using the link in this video's description. To save us some time, I have typed out the prompt we'll use today. It has 3 main sections. The first part sets a scene and says we want a Python node. For now, this is the best way to get AI to help us with writing Dynamo scripts because AI models are not yet capable of adding and connecting vanilla Dynamo nodes. On the other hand, a Python node is perfect as the AI can generate a full Python script for us to copy into Dynamo. Here, I also explicitly ask it to leverage the Revit API in the Python script for avoid any doubts. The second part describes the task we want the script to fulfill. Here I ask it to change the reference type of all Revit links in the active model to relative. Finally, the third part lets us add some guardrails. Just from experience, I know the AI often misses import statements and Revit transaction declaration blocks. That's why I ask it to include those here. I also tell it to output some kind of result back to the main Dynamo script, so we'll see what happened at the end. With the prompt ready, let's open a Revit model to test it. We can use this file here which contains several Revit links. The path type of all links are already relative. I'll change those to absolute so the script can fix this eventually. Back to VS Code, let's copy the prompt we saw earlier and send it to the AI model. When you do this, make sure to select the right request type. For example, if we select Ask, the AI will only answer questions on the existing codebase or gives suggestions on how to solve a problem. It will not modify any code files in our workspace. To let it actually do the work, make sure to set the mode to Agent. The next option here lets us select an AI model to use. We currently only have Auto, but I'll show you in a bit how to get the full list of AI models here. For now, let's send the request and see what happens. As you can see, we need to sign in to one of these accounts to use chat mode. Since the chat panel here works with GitHub Copilot, it's most recommended to use a GitHub account. So let's click here. That will open a browser window for us to log in. I have also logged in to my GitHub account, so here it's easy. I can just click continue and then choose to switch back to VS Code. And there we go. Now the request has been sent and the AI is working. Since this is the first time I use this feature, it may ask for permission to perform certain actions automatically. I'm aware these are safe to automate, so we'll let it do so from now on. Just so you know, the GitHub account I use already has a GitHub Copilot subscription, so it began working right away. If your account doesn't have one, it will work for a few requests and then ask you to start a GitHub Copilot trial. In my opinion, this is totally worth it, so please make use of that trial. At the end of the trial, you can choose to continue using this for $10 per month. For me, the time and money this AI workflow can save absolutely far outweighs that small cost, so I highly recommend it. And there we go, the AI has finished generating our Python script. Let's look at the first result. For this run, VS Code automatically selected the GPT-5 mini model in GitHub Copilot and used only the original prompt. Now, at first glance, this script looks impressive. There's a lot going on. Many imports, helper functions, multiple fallback strategies, defensive coding everywhere. But this is actually the first red flag. If you scroll through the code, you'll notice it tries multiple APIs for external file references. It attempts to recreate external file reference objects. It checks method existence dynamically. It even guesses enum values in some places. What this tells us is the model doesn't really understand the Revit API surface for this task. Instead of using the correct direct property, it's trying to brute force the solution. This kind of code is hard to read, hard to maintain, and very likely to break across Revit versions. So while this script looks smart, it's actually over-engineered and unreliable. This is a very common pattern with smaller or less specialized models. Anyway, let's give it a chance to see if it actually runs in Revit. To test the script, I'll create a new Dynamo script and then added some nodes to read the Python file the AI generated. This script lets me specify the path to a text file, converts that path into a file object, reads the file's content into a string, and then feeds that string into a Python script node. This last node will execute that string as a single Python script and return the result, either successful or failed. In our case here, the Python has failed with an error on line 43. Looking at that line, I can see it tries to get the name of a Revit link type incorrectly. This is not the right way to access this property with the Revit API. To do this the right way, we need to use a better AI model. Remember, we only had the auto option here. Now it's giving us a whole list of different AI models. Those that says 0x on the right are free to use but are quite dumb. The one we used is one of those, GPT-5 Mini. For more reliable results, we should choose a model that has an associated cost but can generate the right script without too much hand-holding. My go-to option is currently Claude Sonnet 4.5. Let's select it here and open a new chat window to start fresh. I can then copy the original prompt from the old chat and paste it to the new one. I'll also tell it to generate the script in the new file and keep the previous one intact. Make sure we're using Claude Sonnet 4.5 and let's send the request. This time, it took way less time to fulfill the request. This can be a good sign that it understands the task and the Revit API better, so there's less for it to look up online on these topics. Anyway, let's see if the output is any better. Immediately, you'll notice some improvements. The intent is much clearer. The logic flow is simpler. The script actually checks part type.absolute versus part type relatives. That's already a big step forward. However, there are still some issues. The import list is massive, and unnecessary entire Revit namespaces are pulled in even though they are not used. Reporting is verbose and mixed with status messages, and the script still does more work than required. So this version is functionally closer, but still not clean. Now, let's run it in Revit to see if it's actually functional. I'll update the Dynamo script to read the new Python file generated and run the script again. Alright, so it failed again with an error. The error message is shown here as a log message, which isn't really helpful as it doesn't show on which line the error occurred. This is because the script uses a try-catch block to catch any error. This is not a good approach. Usually, when scripting for Revit, I prefer to let any error bubble up and display their full details to help with debugging. Let me fix this by removing the try-catch block and then let the core part of the script execute directly. Now, when I run the script again in Dynamo, it shows the error occurred on line 40. Back to the script, let's check that line. Alright, so this is exactly where the last script failed. Although the new, more advanced AI model produced a cleaner script, it seems to still lack in-depth knowledge of the Revit API to prevent some errors in this domain. From experience, I can tell this line doesn't work because the name property of a Revit link type is write only. You can call it to change the value, but not to read it. Here, I removed the noise on this line to only call the property by name. You can see it failed with the same error, which proves calling this property is the core problem to solve here. The correct way to get a link name with the Revit API is by reading one of its built-in parameters and then get that parameter's string value, like this. However, there's a yellow squiggly line under the Autodesk namespace. This means the namespace hasn't been imported into this script. To fix this, I'll just copy the import statements from my own Python script template for Revit. It's in this video's description if you need it. Now the squiggly lines is gone. I can even shorten the property here as the script already knows where it lives based on the imported namespaces. If we run the script again now, we can see it has executed successfully. However, it didn't modify the model as all the links already use relative paths. For demonstration purposes, let me quickly make all links use absolute paths and then rerun the script. This has uncovered a new error. No attribute named create local resource is available. Let's see where it's called in the script. It's here. So what's happening here is when the path type of a link is absolute, the script tries to change that to relative, but it does that using the wrong Revit API method. Let me fix this. Instead of using an instance of external file reference, we can just modify the path type property here directly, as it's an editable property. Let's rerun the script to see if that works. So, not yet. A new error says that property is read-only. Let's see why. Alright, so we're on the right track, but here, instead of modifying the external reference object, we need to edit the link type instance directly. Let's save that and rerun the script. And there we go. It has worked. The log message says the change has been done. If I check the Revit model now, you can see the path type has been set back to relative. So that's great, but it looks like I had to do lots of manual fixes to help the AI make it work. To avoid doing that, we can tweak the prompt a bit to let the AI know which Revit API reference to use. Let me try that. I'll copy the last prompt, open a new chat, paste the prompt in, give it a new file name to generate, and then add a hint on how to use the Revit API correctly for this task. We'll stick with using Claude Sonnet 4.5 in agent mode and send the request. This is an important tip. When working with domain-specific APIs like Revit, one line of expert guidance in the prompt can massively improve the result. Now, let's look at the third script. This is clearly the best version. So what changed? Firstly, the imports are minimal and relevant. Only the required Revit API classes are referenced. Second, the logic is extremely clear. Collect link types, check link.pathType, switch from absolute to relative, store the changed link names. However, there's still a lot of code that only deals with reporting messages. For me, it's enough to only see a list of link type names that have been modified. We can tell the AI model to clean up the script to achieve that. Here, I'm providing a follow-up prompt in the same chat so that we stay in the current coding context. As soon as a new prompt is received, the AI cleans up logging messages from the script to keep only what I specify. I can then review the changes or just accept all modifications like this. Now, reporting is clean. The output is exactly what Dynamo users want, a flat list of modified links. There's no guessing, no reflection, no unnecessary fallbacks. This is what production quality Dynamo Python code should look like. And the most important thing is, the AI didn't magically get smarter, the prompt got smarter. So what should you take away from this? First, don't trust the first AI-generated script, especially for Revit API tasks. Second, when the code looks overly complex, that's usually a sign the model doesn't fully understand the API. Third, if you know a key API detail, put it directly into the prompt. You'll save yourself a lot of cleanup later. And finally, use AI as a collaborator, not a replacement. You guide the direction, the AI fills in the boilerplate. If you're using Dynamo, Revit, and Python regularly, GitHub Copilot can be an incredibly powerful tool as long as you iterate and evaluate critically. You'll still need some understanding of and some experience in using the Revit API, but your development timeline will be significantly shortened as you become more productive thanks to the AI assistant. Before you go, check out our sponsor, Tagatize. Save all your tagging styles in one place and tag one or several views or sheets at once. Also, say goodbye to overlapping tags. Simply review generated tags and make any final tweaks with the handy tag audit commands. Try Tagatize completely for free using the link in this video's description.
If you like this lesson and want more like this every single week, make sure to subscribe to this channel now. For now, have a good day and I'll see you in the next tutorial.